Hello everyone, you are on Vectali. Today's questions on COM and collisions look honestly illogical. You read them once, twice, and still they don't add up. But here's the thing, physics is never wrong, only our perspective is. So in this video, we'll break these illogical problems into simple, intuitive logic. Welcome back to Vectali. Let's decode the chaos. Question number 1. A particle of mass m moving with velocity v makes an head-on elastic collision with a stationary particle of mass 2m. Kinetic energy lost by the lighter particle during the period of deformation. Students might get confused over here because when they term kinetic energy lost is spoken. If you see on an overall basis, in an elastic collision, overall basis, energy loss is not there. Correct? So that is what we learned. So we learned no energy is lost in elastic collision. I'm sorry for my handwriting. Soon I will improve it. Okay, but here what happens is when two bodies, let's say, in similar to our case, of mass m and a body of mass 2m, m is moving with a velocity v. When these two bodies collide, okay, at the point of collision, for example, body m is over here and body 2m is over here, and at the instant it has some velocity v. After this, there will be momentum transfer, right? And on overall basis, the momentum will be conserved, but there will be a momentum transfer between these two bodies. How will they occur? And these two bodies are not point masses, right? So they have their center of mass is here, and their center of mass is here. So what happens? These two bodies deform at this particular instant. Even in elastic collision, they will deform and again come into their original structures. Okay, here, if you have to note that during the period of deformation. So, during the period of deformation, if you notice, you will get a very clear logic that these two bodies will travel with the same velocity. So, during deformation, they have same velocity. That is, they travel with same velocity. So, let me break this. That's it. The question is over. This is the only concept. So mv is the initial momentum. Anyway, as it is an elastic collision, everywhere throughout the whole motion or throughout the whole story, the momentum is conserved. So mv is nothing but m plus 2m into some velocity. Let's assume vt. Okay. Now this is the velocity at which these two bodies are deforming. Okay. So let's find the vt. What is the vt? Vt is nothing but v by 3, right? So we found what is vt. Now the kinetic energy lost by the lighter particle. Okay, let's write the initial kinetic energy, Ke initial, of the lighter particle. I'm speaking only about the lighter particle is half mv square, correct? And kinetic energy final of the lighter particle is half, same mass m, but what is the velocity? Same vt, right? So which is v square by 9. Now delta k is nothing but the kinetic energy lost, right? Which is half m. As it is, we are speaking about loss, I will take negative of it, which I will get half mv square minus half mv square by 9. So Ke lost is nothing but Let me take half mv square common and 1 minus 1 by 9, which I get 8 by 9. So on overall basis, what I get is kinetic energy lost is nothing but 4 by 9 mv square. Question number 2. Two identical small balls, each of mass m, are held on the top of a triangular wedge of mass capital M and height h that is at rest on a frictionless horizontal floor. When the balls are released, they roll down inclined face of the wedge and at the bottom get stuck in special traps. So these are the traps. How far will the wedge shift during the movement of the ball related to the wedge? And I hope we did the similar problem of this kind in our previous video. Okay, this kind of problems are very much important in center of mass. So I'm just doing it again. Okay, and this is of mass capital M, and these two balls have mass small m. Now what happens? Let's see what is the acceleration of the center of mass in the whole thing. Let's consider the balls and the wedge as a system. The acceleration of center of mass is one and only acceleration due to gravity, which is g, which is minus g into j cap. So there is no force or acceleration in horizontal direction, right? So delta x, the change in x coordinate of center of mass, is 0. Correct. Let's write the initial coordinates of center of mass, x center of mass. Let's suppose m is somewhere. Let's consider origin is somewhere, and center of mass of the wedge m lies in x1, and these two particles are just closer, let's assume. So 2m into x2 whole divided by m plus 2m works. Now let's write the final thing, x dash of com. Okay, now let's assume at the final case one ball is over here and the other is over here. Okay, now what happened is this overall wedge, let's assume it moved some distance x. Okay, and we have to find this value x. That is our question, because how far will the wedge shift? Correct. This is the x is the distance shift by the wedge. Okay, now so we are moving in the positive x direction, so m into x1 plus x works. Okay, and if you see body m, the body m comes here, it is always in the contact with the wedge, so it also moves x2 plus x distance. And if you see from here, it moves again a bit of distance. How will we find the distance? See, let's consider this as a triangle, and this angle is nothing but the beta, and this is height h. And let's suppose this is k. So what I get is tan beta is nothing but h by k. Okay, so k is nothing but h cot beta. Again, I get a distance of h cot beta towards right in the positive x coordinate. And if you see for the second mass over here, what happens is x2 plus x occurs, but it goes beyond, right? So minus of h cot alpha whole divided by m plus 2m. Now the initial and final coordinates of the center of mass are same, right? So this term involving x, this thing, and this thing is 0, correct? So mx plus mx plus mh cot beta plus mx minus mh cot alpha is 0, and we want x. So let's group these, this, let's group them. So m plus 2m into x is nothing but, let me take these remaining terms to the right, so m h into cot alpha minus cot beta, and X, which is a required quantity, is nothing but mh into cot alpha minus cot beta whole divided by m plus 2m. So this is the final answer of the question number 2. Question number 3. Two bodies A and B of masses 5 kg and 10 kg moving in a free space in opposite directions with velocities 4 meter per second and 0.5 meter per second respectively undergo an head-on collision. Okay. The force F of their mutual interaction varies with time t according to the given graph. What can you conclude from the given information? So this is a given force time graph, and this is similar to the question number 1. If you see, I have a body A. Okay, let's suppose this is body A and this is body B. Now body A of mass 5 and body B of mass is 10. Now this is moving with a velocity 4 and this is moving with a velocity of half meter per second. Okay. Now these two are colliding, and during the time of collision, there will be a mutual interactive force. So we are plotting the force with respect to time, and after 0.30, the overall these two bodies get separated, so there is no interactive force. Okay. So what are they asking? The period of deformation, coefficient of restitution, and the final velocities. So let's first calculate the impulse produced by this thing. Okay. So if you see, the impulse, which is change in momentum, produced by the interaction. You see, in any kind of collision, the momentum transfer will be done by this force. Okay. So the impulse produced by this force is the reason for the change in momentum of each and every body. So this is actually a triangle. So the formula of impulse is actually integral of f dot dt. And here it's simply the area of this function. So it's a, since it's a triangle, half into the height, which is 150 into breadth 0.3. So what I get is 75 into 0.3, which is 22.5 kg meter per second square, kg meter per second, else I can write as Newton second. Okay. Now what happens is, let's calculate the initial momentum of A. So what is the initial momentum of A? It is mass of A into velocity. Let's consider this is positive and this is negative. So 5 into 4, which is 20 same units Newton second. So impulse is nothing but, I will denote it by J. So what happens is P final of A minus P initial of A is nothing but J. So what I get is P final of A is P initial plus J. But actually here the J varies with sign, because for A the J will be in this direction and for B the J will be in this direction. Okay. So for calculating A, J will be minus. So which I get 20 minus 22.5. So from which I get final momentum of A is minus 2.5. Okay. And also from this I can calculate the velocity of A, which is minus 2.5 divided by 5, which is minus 0.5 meter per second. So the final velocity of A in this direction is half meter per second. So from this we can conclude option C is wrong. Similarly, if I calculate the initial momentum of B, which is nothing but minus 5 Newton second. So final momentum of B is nothing but minus 5, which is plus PIB. And for this, it is plus J plus 22.5 and PFB I get as 17.5 Newton second. Now from this I can conclude the velocity of B is 17.5 by 10, which is 1.75 meter per second. So let's check with the value. Yeah, it's in the reverse direction. Yeah, it is giving us positive 1.75. So D is correct. So now we have the final velocities and initial velocities. Let's calculate the coefficient of restitution. So coefficient of restitution is the velocity of separation by velocity of approach. So what is the velocity of separation here? Mm, the velocity of separation is, suppose, 1.75 minus 0.5, okay, whole divided by, what is the velocity of approach? The velocity of approach is nothing but, both should be combined, that is 4.5. So through which I can conclude 1.25 by 4.5. So which is 125 by 450, right? From 25th table, I can conclude this as 18 times cancelling and this is 5 times. Actually, let me check this. In I did mark the directions wrong, so it is this direction 1.75, so it is in the reverse direction. So this is supposed to be minus of minus, which is plus, and this is 2.25, and this is 25. I get 9, and which is zero point 0.5. So the coefficient of restitution is 0.5. That's correct. So let's calculate the period of deformation. But how will we do it? The same concept. During the deformation, or at the instant where the deformation is completed, both the bodies will move with the same velocity. Right? So what is the mass of A, which is 5, and it's moving with velocity 4. This is the momentum of A. And what about B? B's momentum is minus 5. So during the endpoint of the deformation, what I get is the 15 total mass will move the same velocity V. So what is the velocity? Here gives 15, and so V is 1 meter per second. So when the velocity is 1 meter per second, if you see when the velocity is 1 meter per second, the deformation is just completed. Correct? So when velocity is 1 meter per second, so let's calculate the momentum of some of any of the body. Let's calculate the momentum of A. Okay, when the momentum of A is, mass of A is 5 and velocity is 1, which I get 5. Correct? So what is the initial momentum of A? Which is 20. So what is the change? Which is the impulse? Which impulse is 15? Correct. 15 Newton second. Correct. So actually, graphically, one can say this is the point which we have to find, which is T. Correct. So how will we find T? This overall area is so nothing but we calculated as 15. That is the change in momentum. So this 15 is nothing but the half into height is nothing but 150 into the T. So the T I get is 1 by 5, which is equal to 0.2 seconds. So option A is also correct. This question might be easy, but this includes some of the different concepts because the period of deformation, all these things are not usual. Question number 4. Two particles A and B repel each other by a force of 6 Newton when the distance between them is less than 1 meter, and apply no force on each other when the distance between them is greater than, that is, 1 meter. Mass of particle A is 1 kg and mass of particle B is 3 times of mass A. If the particle B is projected with velocity u, which is 2 meter per second, towards the particle A kept at rest in free space, find the minimum distance between them. Okay. This question can be done with two methods. Let me first do with method 1. So method 1 is nothing but the typical NLM. Okay, simple. I'm just considering the two bodies. So if you consider this body B, let it be somewhere at the distance of 8 meters, suppose. This body B will till it reaches this point. The inertia will make it move, and no other opposition force is there. So when the distance between A and B is 1 meter, exactly just 1 meter, the velocity of B will remain same, and it is U. So let me mark this particle A, okay, and this is particle B, and with velocity U. So what is the distance between them? If you see, the distance between them is nothing but exactly 1 meter. This is the point of time. I'm just drawing this, okay. This is exactly 1 meter. Now at this time, what happens is this experiences a force of F, and this experiences a force of F. Okay, let me term it R naught and generalize it. Okay, now what happens is this mass is M and this is 3M. Now I'm fixing my whole perspective with respect to A, because when the distance between them, at this point A is at rest. Okay, so I'm just fixing my perspective, or what we call, not perspective in physics, what we call frame of reference. So, or frame of reference with respect to A. So when the B reaches closer to the frame of reference, which is less than or not, it experiences force. So if I fix here, this is a non-inertial frame because it's accelerating, right? Until B is less than or not. So the actual force experienced is F. So actual acceleration is F by 3m plus pseudo, which is F by m. So overall, what I get is 4F by 3m. Okay, 4F by 3m acceleration is given to particle B. Now, if you see, when will a body, suppose a body A is here and body B is here, when will it be at the minimum distance? At some point where its velocity is zero, because once its velocity turns zero, it will go back because of this force, correct? So that will be the minimum distance. So its velocity is zero at that particular point, correct? So that must be a rememberable thing. Okay, so this acceleration will make this velocity zero. So u is nothing but, let's suppose that occurs at a time t. U is 4f by 3m, that is the acceleration here, retardation into t. So I get t is nothing but 3m u by 4f. If you see, it's suppose b is at this position at time t. So what are they asking? They are asking only this distance. So which is nothing but r naught minus the travel distance. Let's suppose this is x, is what they are asking. So how will you get x? X is nothing but ut plus half at square, right? So ut plus, here it is a retardation, so minus half 4f by 3m t square. You will find t over here, substitute it, that's it. Khatam. Now let's go to method 2. And this is nothing but energy method. If you see your previous videos, I would be conveying that each and every question can be solved using NLM as well as energy. Let's see which is simpler. In the same energy method, what I'm considering is this literally the same thing. Okay, what happens is initially A is here, and I'm considering a moment where B comes at a distance of R naught. Okay, and it has a energy U. So initial energy initial of the whole system I'm considering A and B is half mu square. Correct. Now what is the final energy? Here comes the fact that when these two particles are closer, suppose this distance is nothing but k, and A is here, B is here, they be in might not need be in rest. As we are conserving energy, we are not keeping with respect to A because A already has a velocity. Since A will also experience an acceleration, B will also experience an acceleration, correct? So A will have some certain velocity, right? So let's assume this velocity is v1. When it is at the closest position, B will also have the same velocity, correct? If B is having a slight more, it will come much closer. If B is having a slight less, it might have been closer in at some particular point before it. So both must have the same velocity. So the energy final is nothing but, initially it's somewhere here. Now A went a distance x from initial position, let's suppose, and B went a distance x plus r naught minus k, correct? Yeah. So energy final is nothing but half mv1 square plus half, let's take eta m into v1 square. Okay. Now the difference is energy is nothing but the work done, correct? So half m u square minus half m into 1 plus mu v1 square is nothing but the work done. What is the work done? The work done by the force F. So F does work on A, which moves a distance x in the same direction. And here it's a negative work in case of B. So F minus F into x plus R naught minus K. Now we have to find a relation between U and V1. So what does U and V1 represent? If you see, F is an internal force, right? If I consider A and B as a system, the momentum will be conserved in x direction because there is no force. F is an internal, no external force. So eta m into U is nothing but eta plus 1 into m into V1. So from this, I get V1 is nothing but eta U by eta plus 1. If I substitute it over here, half m. So what I get is eta square mu u square by eta plus 1, which is force F into K, force F negative of force into, sorry, force to K minus R naught. Okay, let's keep this aside. So if I substitute it and find, what I get is half m eta u square plus u square minus eta square mu square. If you see, the initial energy is eta times because the body mass B has it. So eta times, sorry, eta times mu square. So this would have become this whole divided by eta plus 1 is nothing but the F into K minus R naught. And what I get is half M into, this would have become eta times u square by eta plus 1. So this is nothing but F into K minus R naught. And here, what we really want is this difference. So this thing you can find using by substituting just the values. The main concept I have to bring is you can solve using both methods. Both methods use similar kind of concepts. Think and apply them. I hope you liked this video. If you understood these, nothing in COM and collisions can scare you now. And that's how even the most illogical problems fall into place. This is Victali See you in the next breakdown.